Hello everyone, welcome back to QuickRevise. Today we're going to be talking about density in O-levels syllabus onward of 2023. So this chapter is relatively small and it's going to be very easy if you just try to understand, and we're going to do some questions so that we understand how this concept comes into real life questions. So the first thing that we're going to talk about is density. The definition of density is mass per unit volume. So this means that density is basically the amount of mass that we have in a particular volume. So for example, here I've got a cube which has three sides: length, width and height of 1 meter, 1 meter and 1 meter. So the volume of this cube is 1 meter cube. Now this cube has a mass of 5 kg. Okay, so this cube has a mass of 5 kg, as we can see here. So the density of this cube is mass divided by its volume. So 5 kg divided by 1 meter cube, this gives us 5 kg per meter cube. This is the formula for density. This P denotes density, M is mass and V is volume, and the units for density are kg per meter cube. So you always have mass in the numerator and volume in the denominator, but these are the most common units used. Okay, so the next thing that we're going to talk about is how to calculate density of an irregular object. So in the example above, we had a cube which was regular. It had three sides and we knew the length of each side, and it was a regular cuboid, so we could easily calculate its volume and its mass. But what about a rock with the irregular shape like this? How do we calculate the volume of this sort of rock? Now this is where water displacement method comes in. We've read about it before, but I'm just going to give you a quick explanation. If you want to know how to calculate volume using water displacement, you can check out the video for measurements. So basically you get a measuring cylinder. So you get a measuring cylinder and you pour in some water. Okay, so you pour in water and you mark the reading for when the water is the only thing in the measuring cylinder. So you mark this and it's called M1. The next thing you do is you put in your irregular object inside the water, and obviously the reading will rise, the water level will rise, and you will then mark the second level as M2 after the rock has been, or the irregular object has been put in the measuring cylinder. Now what you will do is you will subtract the later reading with the initial reading, and you will get the volume of your irregular object. We're going to do a question related to this and it will become much more clearer than that. So this is how we calculate the volume of the irregular object, and to calculate the mass we use an electronic balance, and the formula for density, as we know before, is mass over volume. Okay, so now we're going to do some questions to help build our concept. So the first one says that a plastic cube of density P is compressed so that each of its sides become 1/2 of its original length. What is the new density of the material of the cube? Okay, so let's try and understand what was the original density. So we've got a cube here. We will say that the mass of the cube is M and each of its sides is L. So the volume of the cube will be L multiplied by L multiplied by L is equals to L cube. So the density for this cube, the original cube, will be M divided by L cube. Now let's talk about the compressed cube. So the mass will remain the same. The only thing that will differ is its volume, because they've said that each of its sides become 1/2 of its original length. So if the original length was L, 1/2 of L is L divided by 2. So the volume will become L divided by 2 multiplied by L divided by 2 multiplied by L divided by 2, and we'll get L cube divided by 8. Now the density for the compressed cube in this case will become M divided by L cube 8, and if we simplify this equation, we'll get M multiplied by 8 over L cube, which simplifies to M 8M over L cube. Now in the question they've said that the original density of the cube is denoted by P. So the original density that we calculated was m over L cube. Now this m over L cube we can also write as P. So now we have to search the m over L cube in our compressed density. So we've got 8 multiplied by m over L cube. Now we can substitute this m over L cube with P. So we get 8 P and we get the answer D. So the next question says that a stone is placed in measuring cylinder of water as shown. The volume of the water cylinder before adding the stone is 15 centimeter cube and the stone has a mass of 90 grams. What is the density of the stone? Okay, so the original volume was 15 and after we added the stone the volume becomes 75. So we know that the formula to calculate the volume of an irregular object is final, which is 75, minus initial, which is 15, so we get 60. So we know that the volume of our stone is 60 centimeter cube and the mass that we have is 90 grams. Now the one thing that we need to make sure is that our units are correct. So we've got the mass in grams and the volume in centimeter cube, and if you look at our options we can see that all of the options have the answers in gram per centimeter cube. Now this means that we don't need to do any change in units, so we can just simply solve this. We know that the formula for density is mass over volume. So density is equals to 90 divided by 60. If we put this in our calculator, we can see that our answer comes down to 1.5 grams per centimeter cube. So our correct answer is C. Okay, so this is a P2 question, so let's start. They say that in figure 1.1 shows a jug of liquid and an empty measuring cylinder that is on an electronic balance. The part says that describe how to determine the density of the liquid using the apparatus shown in figure 1.1. So density, as we know, is mass over volume. So we need two things. One of them is mass and the other is volume. So let's talk about volume first. You've got a measuring cylinder, so we just simply put the liquid in the measuring cylinder and we'll get the volume of the liquid. So the first step is going to be pour the liquid in the measuring cylinder and find its volume. The next thing that we need to do is we need to find out the mass for this liquid. Now we can't just put the liquid on top of the electronic balance because it will obviously flow out, so we need to put it on the measuring cylinder. But if you see that if we put the liquid in the measuring cylinder and take the reading will be the mass of the liquid plus the mass of the measuring cylinder. So what we need to do is that we need to find out the initial volume, initial mass, which is of the measuring cylinder alone. And as we can see in the question, we have 34.9, which is the mass of the measuring cylinder. Next we'll pour in the liquid into the measuring cylinder and we'll mark the mass. So whatever mass we get, it's going to be measuring cylinder plus the liquid. So if we subtract the mass of the measuring cylinder from that final reading, we'll get the mass for the liquid alone. So the next thing that we do is we pour liquid in the cylinder and mark its reading. After that we're going to subtract the final reading from the initial reading so that we can cancel out the measuring cylinder mass. So we're gonna subtract, okay, so after that we're going to subtract the initial reading from the final reading. So we're going to subtract 34.9 grams from final reading to find mass of the liquid And in our last point, which is simply going to divide mass with volume to get density. Okay, moving on to the C part, we have that the density of the liquid is 780 kilograms per meter cube. Determine the volume of 0.65 kg of this liquid. Okay, so the density, we know that density is equals to mass over volume. We have density and mass, we need to find volume. So what I'm going to do is I'm going to simply write 780, which is the density, is equals to mass, which is 0.65, divided by volume, which we need to find. I'm going to switch volume to the left hand side and we'll get 0.65 divided by 780. Now if we put this into the calculator, we get the answer, the 8.3 multiplied by 10 raised to the power minus 4, so the volume will be 8.3 multiplied by 10 raised to the power minus 4. We're gonna write this 8.3 multiplied by 10 raised to the power minus 4. But you know, even if you write this, we're only gonna score 1 mark. Why? Because we didn't write the units. So the units are very important and you need to write the units along with the volume or whatever quantity that you're writing. So in this case, the units are going to be meter cube because we're talking about volume. And in our question, we can see that the density has meter cube in its unit as volume. Okay, so with this the chapter density also comes to a conclusion. I hope you guys understood, and if you have any problems, you can leave them down in the comment section below and I'll answer all of your queries. Thank you for watching and have a good day.